Hello students, welcome back to a new mathematics program for grade 8. In today's video, we are going to talk about indices. Remember that this is a chapter that was already discussed at grade 7. For grade 8, we shall learn some more rules and properties of indices. Now students, consider the following. 3 times 4 power 2. We have a bracket with power 2. We know that indices is used for repeated multiplication. Here we have 3 times 4 power 2. So this bracket containing 3 times 4 will be repeated twice. So we have 3 times 4 times 3 times 4. Now let us group the 3's together and the 4's together. We have 3 times 3 times 4 times 4, which can be written as 3 power 2 times 4 power 2. Another example, in one bracket we have 5 times 2 with a power 3. This bracket is repeated 3 times because the power is 3. Now let us group all the 5's together and the 2's together. We have 5 times 5 times 5 times 2 times 2 times 2, which can be written as 5 power 3 times 2 power 3. We can generalize these two results as a rule. That is, if we have AB in a bracket with power x, it can be written as A power x times B power x. That is, the power x, it belongs to both A and B. Let us use this rule in some examples. If we have 3 times 4 power 2, it is equal to 3 power 2 times 4 power 2, which can be evaluated as 9 times 16 equal to 144. Suppose we want to calculate 15 to the square. Instead of calculating 15 times 15, we can write 15 as 3 times 5, here with the power 2. Using the rule which I have just discussed, we have 3 power 2 times 5 power 2. It is equal to 9 times 25, and the answer is 225. So we have evaluated 15 to the square without performing the multiplication 15 times 15. We have written 15 as 3 times 5 using the power 2, and we end up with the same answer of 15 to the square, which is 225. Can you think about 40 to the cube without performing 40 times 40 times 40? Yes, we can use 4 times 10 power 3, which is equal to 4 power 3 times 10 power 3. It is equal to 64 times 1000. So the final answer is 64 thousandths. Now 24 to the square. Can you think how can we simplify 24 to the square without performing 24 times 24? I know you are thinking about 2 times 12, 3 times 8, 4 times 6. Okay, here let's use 2 times 12. 24 is same as 2 times 12. We have the power 2. So we'll end up with 2 power 2 times 12 power 2. It is equal to 4 times 144, and the answer is 576. As such, you can perform various calculations using this rule of indices. It will help you to find big numbers without using calculators. Now consider the following. We have 3/4 power 2. What shall we write? We have a bracket with power 2. So this bracket is repeated twice. That is 3/4 times 3/4. It is equal to 3 power 2 over 4 power 2, because we have repetition of 3 twice and repetition of 4 twice. It is written as 3 power 2 over 4 power 2. Same for 1/3 power 3. We repeat the 1/3 3 times because of the power 3. It is equal to 1/3 times 1/3 times 1/3, which can be written as 1 power 3 over 3 power 3. Again, these results can be generalized as a rule of indices, which is a over b power x equal to a power x divided by b power x. That is, this power x belongs to both a and b. Let's have a look at some examples. Here we have 2 over 3 power 3. Instead of writing 2 over 3 times 2 over 3 times 2 over 3, we can simply write 2 power 3 divided by 3 power 3, which is equal to 8 over 27. 3/4 power 3, it is equal to 3 power 3 divided by 4 power 3 equal to 27 over 64. What about half to the power of 5? Yes, it is 1 power 5 divided by 2 power 5 equal to 1 over 32. We can use this rule to find the square of 0.1, that is, evaluating a decimal number with a power. We can write the 0.1 as a fraction, which is 1 over 10. We have a power 2, so we have here 1 power 2 divided by 10 power 2, which is equal to 1 over 100. If you want to write it again as a decimal number, it is of course 0.01. Now let's talk about negative indices. You all know about negative numbers. We are going to write the powers as a negative number. For instance, if we have a power minus x, this can be written as 1 over a power x. Have a look at the power. So far, we have used positive numbers as powers. Now, we are using a negative number. This negative power can be written as positive power if we take the reciprocal of the number. We have here a power minus x. We can write the x as positive x only if we write the a in the denominator. For example, 2 power minus 1. It is same as 1 over 2 power 1, which is of course half. So 2 power minus 1 is same as half. Let's have a look at another example. 3 power minus 2. If we want to write it as a positive power, it is same as 1 over 3 power 2, which is equal to 1 over 9. Let's have a look at some more examples. 5 power minus 2. It is equal to 1 over 5 power 2 equal to 1 over 25. 4 power minus 3. 1 over 4 power 3 equal to 1 over 64. 10 power minus 3. 1 over 10 power 3 equal to 1 over 1000. So students, now let us use power law involving fractional indices. You all know what is power law. You have learned it in grade 7. Here also we are going to do the same operation. We have two different powers. One is x and the other one is 1 over y. As you can see here, we have one whole number and one fraction. The same law applies here. Power law, we just need to multiply them. For example, if you have 2 power 3 with another power 1/3. So we have to multiply 3 by 1/3. Of course, the 3 will get cancelled. We shall end up with 2 power 1 is equal to 2. Let's have a look at another example. 5 power 4 power 1/4. When multiplying this 4 by 1/4, the 2 4 will get cancelled. We have 5 power 1, which is equal to 5. Now, students, let's use prime factorization to evaluate numbers. 8 can be written as 2 times 2 times 2. That is, as a product of its prime factors, which is equal to 2 power 3. Now, if I want to evaluate 8 power 1/3, instead of writing 8, I can write 2 power 3. We have the power 1/3. These two 3 will get cancelled. We have as answer 2 power 1, which is equal to 2. Similarly, since 27 is equal to 3 times 3 times 3, it is equal to 3 power 3. 27 power 2/3 is equal to 3 power 3 power 2/3. These two 3 will get cancelled. We have as answer 3 power 2 equal to 9. Let's have a look at some more examples. 125 power 1/3. We can write 125 as 5 to the cube. These two 3 will get cancelled. The answer is 5. 32 power 1/5. 32 can be written as 2 power 5. With the 2 5 being cancelled, the answer is 2. 16 power 3/4. We can write 16 as 2 power 4. The 2 4 will be cancelled. So the answer is 2 power 3, which can be evaluated as 8. Remember that 2 power 3 is 2 times 2 times 2. Look at this number now. 36 power half. 36 as a product of its prime factors is 2 power 2 times 3 power 2. We learned previously that the power half belongs to both numbers in the bracket. So we have 2 power 2 power half times 3 power 2 power half. The 2 will be cancelled while performing the multiplication. We have 2 times 3 as the answer here, which is of course 6. Let's have a look at another example. 216 power 2/3. 216 is same as 2 power 3 times 3 power 3. We have 2 power 3 power 2/3 times 3 power 3 power 2/3. The 3 will be cancelled through multiplications. We have 2 power 2 times 3 power 2. The answer, of course, is 4 times 9 equal to 36. Here you can see that we have evaluated 216 power 2/3 to obtain an answer of 36. Look at this number now. 8,000 power 2/3. 8,000 is written here as 2 power 3 times 10 power 3. Can you think about the answer? Yes, it will be 2 power 3 power 2/3 times 10 power 3 power 2/3. The 3 will be cancelled. We have 2 power 2 times 10 power 2. The result is 4 times 100 equal to 400. Look at this number now. 25 over 49 power half. 25 is 5 to the square, while 49 is 7 to the square. Applying the rules that we have learned so far, we have 5 power 2 times half, 7 power 2 times half. While performing the multiplication with the powers, the 2 will be cancelled, so the answer is 5 over 7. Similarly, for 16 over 25 power half, 16 is written as 4 power 2, and 25 is written as 5 power 2. Applying the rules of indices, we end up with an answer of 4 over 5. Again, for 8 over 27 power 2/3, 8 is written as 2 power 3, 27 is written as 3 power 3. Applying the rules of indices, we end up with an answer of 4 over 9. Students, now I'm giving you some exercises for practice. You're going to evaluate these numbers. Use the rules and properties of indices that have been discussed so far to obtain an answer for the following. Students, now let's do a summary of whatever we have discussed in this video. We have seen that ab power x can be written as a power x times b power x. A over b within a bracket power x is same as a power x divided by b power x. A power minus x is equal to 1 over a power x. Finally, we learned that if you have two different powers, even if one is a whole number, the other one is a fraction, power law applies, so we just need to multiply these two powers. So students, these are some links where you can log on in order to have more information on the chapter Indices. So students, this program on indices ends here. Work out the exercises for more practice. Goodbye and see you soon for another program. Thank you very much.